Hello my dear student, good evening you all. I am Rakesh Chaubey from Sunbeam Sun City. Jai Hind my dear. My dear, today with respect to the dimensions of physical quantity, let me suggest you that today I will go for finding the dimensions of this 20 physical quantity I have written in front of you. 20 physical quantity. Now these 20 physical quantity which are they, I have written, you also please go through with this. Energy denoted by capital E, torque denoted by tau. As soon as I will giving the explanation for this quantity, I will explain their abbreviations also. So energy, torque, gravitational constant, linear mass density. I repeat, linear mass density or linear density, surface tension, angular velocity, frequency, electric charge, electric potential, electric resistance, potential gradient, pressure gradient, temperature gradient, velocity gradient, coefficient of viscosity, Planck's constant, universal gas constant, electric field, magnetic field, and last elasticity constant. My dear, there are many more apart from this 20, but my request is that why I am doing this 20 dimensions for you all, so that when you will start solving the problems related to dimension, this 20 dimensions you will observe at least in your chapter. I am sure that some of the quantity which I have written, even you have not heard about it. You have never, and if you heard, you not know much about it. No issues. As soon as I start calculating their dimensions, I will give bit theory also about that particular physical quantity. Believe me, I will give small theory also about that physical quantity. So this particular video is very important to you all. And my dear, to crack these 20 dimensions, as I told you, to crack these 20 dimensions which I have written in front of you, my dear, these 5 dimensions are very important which I already done. Out of that 10 dimensions, if you remember, I told you these 5 dimensions, and they are dimension of velocity. This is velocity V. Dimension, I told you, whenever you write the dimension, put box bracket. So I will read this dimension of velocity is L1 m1 m0 t minus 1, L1 m0 t minus 1. Similarly, dimension of acceleration L1 m0 t minus 2, dimension of force L1 m1 t minus 2, dimension of work L2 m1 t minus 2, and dimension of pressure is L minus 1 m1 t minus 2. My dear, this 20 dimensions can more or less depend upon these dimensions. This 5 dimension, before going to this, every student, those who are observing this video, should learn this at least 10 may say 5 dimensions very well. And these are these 5 dimensions, that is dimension of velocity, dimension of acceleration, dimension of force, dimensions of work, and dimension of pressure. So my dear, let us start with the first dimension, that is the dimension of energy. So now let's begin with the dimension of energy. The very first is dimension of energy. My dear, if anybody will ask you, you all know that why I am doing the energy dimension, since I have done this dimension. If anybody will ask you, my dear, what is the dimension of energy, don't be panic. Just say this, sir, work is a form of energy. I said work is a form of energy. So the dimension of energy is same as, I am writing here energy, dimension of energy is same as the dimension of work. And the dimension of work, you all know, answer is L2 m1 t minus 2. That's all over. The first answer is over. Dimension of energy is same as the dimension of work. And since I already in my video I already make awareness that how to find dimension of work by taking the formula force into displacement. There I told you that in dimension, displacement distance doesn't make a sense because we take a magnitude. We are not interested in direction. जब मैं स्केलर वेक्टर करूंगा तो distance and displacement are different. But my dear, as far as dimension part is concerned, sir, distance, displacement, radius, everything is measured in magnitude, and that is called length. There is no direction consideration while taking dimensions. Okay. So my dear, it is force into displacement, or displacement can be distance in this topic because we are taking displacement as length. Uska magnitude, we are not taking direction, though displacement is a vector quantity. But please don't take displacement right now because we are not interested in scalar and vector. So distance is taken as distance, displacement is taken as distance. Okay, we are not taking the directions because displacement में distance भी होता है, direction भी होता है. But मैं क्या बोल रहा हूँ? I am saying you that direction don't consider because I am writing dimensions. So displacement का direction is L power, dimension is L power 1 only. So the total dimension is nothing but L2 m1 t minus 2. That's all. Energy dimension is over. But here one more thing. If anybody will ask you what is the dimension of kinetic energy, sir, it is same as the dimension of energy. Dimension of potential energy, it is same as the dimension of energy. Dimension of total energy, it is the same as the dimension of energy. Please don't get confused with the word kinetic or potential. There is no dimension for kinetic or dimension for potential. There is a dimension for quantity called energy. So kinetic energy, potential energy, total energy, normal when you say energy, it is the same dimension and the final dimension is the same as the dimension of work. Because energy ka unit is also joule. Okay. So I hope first dimension is over. Similarly, in initial velocity, final velocity, if anybody will ask, don't confuse. Initial and final doesn't make a sense. It is ultimately velocity. So dimension of initial velocity is also same as dimension of only velocity. Dimension of final velocity is same as dimension of velocity. Don't get confused with the word initial and final. Okay. Now let's go to the next part. The next part is torque, denoted by tau. Please, here it is written tau, T-A-U, tau. Let's go to the again. My dear, I hope in my physical world topic I have explained you what is torque. Torque is nothing but force into perpendicular distance. Force into perpendicular distance. So look at the fantasticity. So dimension of torque will become dimension of tau. Here I have written dimension of torque, that is dimension of tau is equal to dimension of force L1 m1 t minus 2 multiply by perpendicular distance. I don't need a perpendicular. The quantity is distance. Here again it is L power 1. So what is the dimension of torque, my dear? Dimension of torque, that is tau, is nothing but L2 m1 t minus 2. Oh God! Dimension of torque, dimension of work or dimension of energy. You can see they are same. They are same, my dear. So which two physical quantity has the same dimension? There are many physical quantity which possess the same dimensions. But here in front of you I am giving you the right answer. Torque and work, you can see the torque and work both has the same dimension, that is L2 m1 t minus 2. I hope it is clear. But my dear, about unit is concerned, the work has a unit of joule, the work has a unit of Newton meter. Please take care, ये सब मेरे वीडियोस में आप देख लेना. Work has a unit of joule, work has a unit of Newton meter, and work has a unit of here mass is kilogram, L square is meter square, and t power minus 2 is second power minus 2. My dear, work has three units: joule, Newton meter, joule, that is work unit, Newton meter, that is formula unit, force into displacement. So force is Newton, displacement is meter, and another unit we are getting through the dimension, sir. M power 1 मतलब kilogram, L power 2 मतलब meter square, and t power minus 2 मतलब second power minus 2. My dear, in my video I have given all this idea that work has a three unit. So about torque also, sir, look into the dimension of torque. M power 1 मतलब kilogram power 1, L power 2 मतलब meter square, and t power minus 2 second power minus 2. So sir, this also is the same as the work. Unit of torque is also same as the work. Look at it. But do you think all three unit is possessed by the torque? That is the question. So here, and the formula says the unit of the torque is force into distance, that is Newton. Force is Newton and distance is meter. Matlab Newton meter is also the unit of torque. तो 2 यूनिट तो टॉर्क possess कर रहा है, but my dear, torque will not possess the unit of joule. Please, ये आप नोट कर लें. That torque don't have the unit of joule because joule is the name of scientist, my dear, and work has experimentally defined and derived by a scientist called Joule. Joule has defined work. Joule has done number of experiment to understand work. So entire credit of researching work is going to Joule. And therefore, my dear, this unit Joule is only applicable to work. Though torque has the same dimension, but torque don't have work ka joule unit. Rest 2 unit Newton meter and kilogram meter square second power minus 2 is possessed by the torque also. Because torque ka formula is force into distance, work ka formula force into displacement. So Newton meter is as it is. Here also Newton meter is applicable. Torque unit is Newton meter. Work unit can be Newton meter. But my dear, this is the reason why while writing work, we don't write the unit Newton meter. We express the work only with one and one only quantity, and that is joule. So ये सब आप अभी रीजन समझ लो कि वर्क में we don't write Newton meter unit. Whenever we write work, we express the work with a unit joule, so that this kind of a controversial or this kind of a confusion should not create. So better to avoid any confusion, we don't use a Newton meter in work. We write work only with one unit, that is joule, or at the most you should know 1 joule is equal to kilogram meter square second power minus 2. This is also equal to joule. But here, please, torque may don't use a word joule, because joule is the scientist name who work only to discuss or define or discover a quantity called work, not torque. So I hope you will understood this particular concept. It's my duty to give you the concept simultaneously. So this is the reason why, my dear, I told you that here you can see work and torque both have the same unit, same dimension. But about unit part is concerned, joule is possessed by work, torque is given by Newton meter or kilogram meter square second power minus 2. Okay, so let's go to the next quantity, gravitational constant. My dear, gravitational constant denoted by capital G. Now you all know that in class 9th you have studied the gravitational force is directly proportional to product of mass. That is, say this is the mass of the earth and this is the mass of planet. दो mass, एक earth का mass और एक planet का mass, right? And it is inversely proportional to square of distance. मैं basically आपको करवा रहा हूँ. So now this can be written as, sir, gravitational force is equal to, this proportionality sign is removed by equal to, this become, I am writing here, therefore this is F is equal to G, M, both are mass, right? Both is mass, so it will be M square divided by R square. No problem, one mass is a higher value, other mass is a lower value. But my dear, I am finding dimension. I am required quantity. I required fundamental quantity. I don't require any number, any value. Number वैसे भी dimensionless होता है. Number don't have dimensions. So here this mass is more value and this mass is less value. What is to do with that? Both are mass and therefore I multiply both mass and I got mass का square. And I got the formula F is equal to G M square divided by R square. Okay. Now from here, my dear, therefore G is equal to, when I transform, rearranging the equation, rearranging the terms, I will get G is equal to FR square upon M square. है ना? FR square, F into R square upon M square is equal to G. And now let us start finding gravitational constant. So dimension of gravitational constant is equal to dimension of F multiplied by dimension of R square divided by dimension of M square. So now this will be dimension of G is nothing but dimension of force, that is L1 M1 T minus 2. I hope you remember force का dimension. Dimension of R square मतलब length का square. So I have written dimension of force L1 M1 T minus 2. R square, that is L power 2, divided by dimension of mass का square M power 2. So what is the dimension of gravitational constant? Therefore dimension of gravitational constant G, that is dimension of G, ऐसे express करने का बेटा, and this is equal to, you can see, this is 1 and this is 2, this is L power 3, 1 and 2, because here it is multiplication. So 1 and this 2 will be L power 3, this is M power 1 and this is M power 2 will go up, become minus 2, and this is 1, 1 minus 2 is minus 1, so this is M power minus 1 and T power minus 2. This is the dimension of gravitational constant. So my dear, I have shown 3 dimensions in front of you. Energy, that is nothing but work. The same dimension is work. Don't confuse with kinetic, don't confuse with potential. Kinetic potential nothing doing, it is a dimension of energy. Sir, it has the same dimension as the work. We all remember work ka dimension L2 M1 T minus 2. So energy dimension is same. Second is torque. Sir, torque is force into perpendicular distance. Sir, perpendicular doesn't make a sense. It is force into distance. Force ka dimension L1 M1 T minus 2, distance L power 1. Total dimension become L power 2 M1 T minus 2. Oh God, this is the same dimension as the dimension of work. But the unit possessed by torque is Newton meter, whereas the unit possessed by work is joule. Standard unit. So that we should not have any confusion. I hope it is clear. At the most, Newton meter is taken for the work also, because force into distance is there in the formula. But we write the unit, proper unit for work, SI unit जिसको बोलते हैं, आगे जाके we say SI unit. So whenever we ask SI unit for work, it is joule. Joule. And SI unit for torque is Newton meter. Force के लिए Newton, distance के लिए meter. Newton meter. But dimension for this two quantity is same. Take care in the exam, if such question is there, which two quantity has the same dimension? You can say work and torque. I will show many also, there is coming more dimensions also, but right now it's easy answer, work and torque possess the same dimension. You cannot say work and energy, because work is a form of energy. I have taken energy externally in separate way, but जानबूझ के लिया है, so that you should aware this language also, that work is a form of energy. So don't say work and energy has same dimension. Instead of say work and torque has the same dimension. I hope it is clear, because energy is ultimately a work, is a form of work. Work is a form of an energy. Na? So don't say work and energy has same dimension, because work itself is a form of energy. So instead of that, say work and torque has the same dimension. Okay. And gravitational constant, you all know that F directly proportional to product of masses, inversely to square of distance. Product of masses, here mass of planet and mass of other planets, say moon is taken, two planets mass is taken. Doesn't make a sense, sir. The mass of planet can be higher and one will be lower, but ultimately it is mass. So mass and mass get multiplied, it become m square. Proportionality sign is replaced by gravitational constant capital G. And the formula become F is equal to G m square upon R square. I am interested to find the dimension of G. I am not interested to find the dimension of force. Na? Force I already know. So dimension of G, how I will calculate? By rearranging the terms. I rearrange the term Fr square divided by m square. Here I substituted F, dimension of R square, dimension of m square. Dimension of F is L1 M1 T minus 2. R square is L power 2 divided by dimension of m power 2, that is mass square. I solve this, this is 1, this is 2, L power 3, this is 1, this is 2 down, so it go up m power minus 1 and T power minus 2 as it is. I hope, please pause the video for a moment, write this 3 dimension, and then I will go for linear mass density. This way I will cover entire 20 dimensions in front of you for today's video class. So my dear, now let's go to the fourth dimension, that is the dimension of linear mass density. Linear mass density, and one more name I have given, instead of calling linear mass density, my dear, this is also called linear density. Linear density, and denoted by small m. Look at it, small m. Generally, student looking small m and say, sir, it is mass. Sorry, please look at the carefully. It is not mass. It is linear mass density. And shortcut at the most we say linear density. This all you will observe in chapter 1 while doing the best numericals from NCERT under dimensions. So now my dear, what is this concept? Now linear density is a concept in solid. Let me tell you, you please listen to my video carefully. It is in solid, sir, and in solid also, this is because in matter it is coming in which matter. This concept, this quantity is for solids. And in solid also where this quantity exists. For example, my dear, you take a string, right? You take a string. I said string. So if you take a string, my dear, that string has some length. Am I clear? And string is solid. So string has some length. Say I have taken 2 meter long string, and then I will measure the length. L is the length of the string. So I will measure the length of a string, and I will measure the mass. Capital M is a mass of a string. है ना? String के पास mass होगा. String के पास mass है because I said 2 meter long string. तो 2 meter long है तो उसके पास कुछ mass तो होगा string के पास. So now I calculated mass of a string. I calculated length of the string, and therefore, my dear, the formula of linear density small m, that is the linear density. This is linear density or linear mass density. मैं shortcut बोल रहा हूँ. Linear density small m formula is mass of string divided by length of string. It is not only mass. Don't tell by looking small m, sir, it is mass. It is mass divided by length, called linear mass density, called mass divided by length. And now I think dimension is easy, Chaube sir. The dimension of linear density is equal to dimension of mass divided by dimension of length. So what is the dimension of linear mass density? It is L power minus 1, because here it is 1, m power 1, L power 1. So L power minus 1, m power 1 and t power 0. That's all. I finished the dimension of linear mass density. And the answer is L power minus 1, m1, t0. If anybody will ask you what is the unit, so easy, Chaube sir. Unit of linear density. Here it is kilogram. Mass का kilogram, L power minus 1 is meter inverse, or you can write kilogram per meter. तो आप ये प्रैक्टिस भी रखो. किसी भी क्वांटिटी का यूनिट डायमेंशन देख के यूनिट लिख देना. Please, by looking the formula also you can write, no issue. This is mass in numerator, that is kilogram, and length in denominator, that is meter. So answer will be kilogram per meter. और dimension देख के भी be very quick and cautious. m power 1 मतलब kilogram, L power minus 1 मतलब meter power minus 1 can be written as kilogram per meter. दोनों वे से be very attentive. Now let's go to the fifth physical quantity. The fifth physical quantity is surface tension. Surface tension, denoted by sigma, right? This is called sigma. मैंने बोला था I will teach you abbreviations also. This is sigma. This is small m. This is tau. This is tau. Tau. This is capital G. कुछ लोग वैसे के वैसे ही है. And this is sigma. Okay. Now surface tension denoted by sigma. Sir, where you observe this quantity? Because मैंने आपको बोला है, I told you all, my dear, that I will teach you small concept also. I am not teaching directly the dimension, not giving directly the formula. So my dear, about surface tension, my dear, this surface tension is a phenomena, is a quantity, is a kind of a phenomena actually. And this phenomena is due to the property, it is one of the property, it is a phenomena which is due to the property of the liquid. Surface tension is one of the property of the liquid. Liquid का एक property है my dear, fluid में है. So when we discuss a chapter called property of fluids, you have this chapter somewhere, the chapter number 8 or 9. Now in that chapter, my dear, we will have this quantity, and this quantity is called surface tension. मतलब surface पे, liquid के surface पे tension आना, stretch होना. My dear, I'll show you the example. There are a lot of example of surface tension. You all know that when you are writing on the paper, your ink gets spread. The ink spreading on the paper is a property of surface tension. The ink spreading is a property of surface tension. When you are cleansing the cloth, cleansing of the cloth is also due to the surface tension. Am I clear? The oil in the laltane, you all know laltane. The oil rises up. The oil rises up in laltane is a property of surface tension. The rise of the liquid in a capillary. Our nose is a capillary. You know, and कई मर्चा वर्चा कोई भूजते रहता है कुछ all that somebody is using that, or you can take ammonia in front of you and just smell ammonia. Ammonia will rises up in your nose. It's a capillarity action because nose is capillary. Why? Property of surface tension. Surface tension. It is related to fluid property. Surface tension is a fluid property, my dear. And believe me, my dear, एक story बोलता हूँ. Long back, you must have heard, your mummy papa also knowing about this story. Please let me complete this. Once we are discussing, we should discuss well. Long back, Bhagwan Ganesh ka that Bhagwan Ganesh ka soon is like a capillary. It's a capillary. You can see the structure. पहले broad होता है, and then it become narrow. This is a kind of a structure. It is a capillary. And what is happening along back? ऐसा न्यूज में भी आ गया. In summer time, somebody was taking the milk near the soon of Ganesh ji, and what is happening, you know, that milk rises up in the soon, that is in the capillary, and then everybody starts saying, अरे गणेश जी तो मंदिर में दूध पी रहे हैं. My dear, this is no doubt, this is one of the belief that गणेश जी मंदिर में दूध पी रहे हैं. The capillary, जैसे ही सूंड के यहाँ दूध लगा रहा है, दूध is rising up. Am I clear? But my dear, scientific reason of that was surface tension. It was too. This was happening when it is too hot. That's a property. So ultimately, surface tension is a kind of a property of a liquid, property of a fluid. And my dear, the formula of this surface tension, I am writing dimension of surface tension. The formula is force divided by length. Oh, force divided by length is the formula. So मैंने आपको concept दे दिया कि this topic, this physical quantity is used as a property of fluid, surface tension, spreading of ink, right? Rising of oil in laltane. Even when you take a ink dropper, when you are filling the ink, right? From the ink pot, the ink that rises up in that dropper, can see that all is a property of surface tension. Cleansing of clothes, right? So this is the formula, my dear, that is force divided by length. Oh God, force is so important in life. That's why I told कि force का dimension orally आना चाहिए. So what is the dimension of force? It is L power 1, M power 1, T power minus 2 divided by length ka dimension L power 1. So dimension of sigma, that is dimension of surface tension, will be nothing but L power 1 and L power 1 will become L power 0, M power 1, T power minus 2. That's all. Dimension for surface tension is over. So what is the formula? Force divided by length. What is the formula for linear density? Mass divided by length. Mass divided by length is linear density. Force divided by length is surface tension. Am I clear? Now my dear, let's go to the sixth quantity. I am pausing the video here so that you please write it down, and there is no space because I don't want to rub this quantity because it should be in front of you that which quantity I am keep on taking. So my sixth quantity, before I'll go to that, I am pausing the video. You also pause the video for 1 or 2 minutes. Write it down and then we'll go for the next. Now my dear, dimension of angular velocity, the sixth quantity, dimension of angular velocity, and it is denoted by omega. Please try to understand the denotation is omega. My dear, एक बार और, while teaching solid angle in my video, I told you this sign is also omega. This can be ohm also, but we said this is d omega. I have taught today another way of writing omega. Another way of writing omega is this. You can see, and how we are writing. Sir, we are making, don't make W. Wrong. Don't make W. It's not W. How we are writing? See, we are turning like this. Okay, so something small w, but not small w. Small w is also this now. We are not writing that way. So what we did, you can see there, I am writing in this way. I am writing this and I am turning like that. Okay, so it is called omega. That is one thing. Now let's go for it. What it is, my dear. Here I will take a time to explain. My dear, there is one velocity which we have studied in the same from lower class, and the velocity is called concept. Here I am writing concept. Linear velocity. Linear velocity, generally, which you have studied, you are not knowing. I hope if you are knowing, then it is good. My dear, this velocity you are studying from class 6th, 7th, and that is denoted by V. And everybody knows, sir, it is distance upon time, yeah, displacement upon time. Everybody know this definition. So rate of change of displacement is called velocity. But my dear, as thoda sa you do some correction in your life. The one you are saying, the rate of change of displacement, actually that is rate of change of linear displacement. I am writing here, linear displacement upon time is called linear velocity. It's called linear velocity, linear. And what is linear? Sir, linear का मतलब होता है that is moving in a straight line. Linear मतलब straight line. So my dear, up tak I think you must be understood that this velocity which you studied from class 6 is nothing but for a linear, that is straight line motion. But now my dear, when we study circular motion or when we study rotational motion, here I am writing circular or rotational motion. Please, this topic is very important. Rotational motion. Now in such topic, the displacement will not cover in form of linear path. It will cover, the displacement will cover in the form of curving path, curve path. And this curve path, say here is A, and the particle move from A to B. My dear, it traces an angle at the center. It traces the radius, here also radius, here also radius. O to A is radius, O to B is radius, and particle, say I myself, move along the circular path, taking cycle. So my dear, here no doubt particle has a linear displacement also by drawing tangent. I am not going to linear path. But here the particle cover a angular displacement at the center called d theta. You remember I have taught the concept of plane angle. I have taught you the concept of plane angle. And my dear, this plane angle which I have told earlier while discussing of plane angle is now today become, this d theta is now today called angular displacement. Angular displacement. This d theta is called angular displacement. Why it is angular displacement? Sir, here the displacement on the circular path is in the form of angle. ये जो डिस्प्लेसमेंट हो रहा है सर्कुलर पाथ पे, द डिस्प्लेसमेंट विच इज ऑन द सर्कुलर पाथ is in the form of angle. It making angle at the center. Suppose particle is reach here. From here to here. So this much here. So this much will be the angle. So this much is the angular displacement. I hope it is clear. So whenever we are moving on the curve path, we are making the displacement in the form of angle at the center. I hope it is clear. So nice of this theory. Suppose, my dear, I have taken this path. Suppose the particle is here, A, and the another particle is here, say, B. So now what will be the displacement? This is the center. So here I will draw this, here I have draw this. Say particle move from A to B this way, clockwise. So this is the angular displacement. Here the particle is moving anti-clockwise. So this is the angular displacement A to B. And here the particle moving A to B like clockwise, because while moving on circle, it can be clockwise or it can be anti-clockwise. But my dear, we are moving on the curve path. तो फिर डिस्प्लेसमेंट कैसे मेजर होगा? द डिस्प्लेसमेंट इज मेजर्ड एट द सेंटर बाय ड्रॉइंग एंगल, एंड वी कॉल दिस एज एंगुलर डिस्प्लेसमेंट. व्हाट डू यू कॉल दिस? एंगुलर डिस्प्लेसमेंट. It's not a linear displacement, it's angular displacement. So my dear, what is the concept? Sir, linear velocity is linear displacement upon time. So easy. So linear velocity is linear displacement, that is s divided by time t, and sir s का dimension is l power 1, time का dimension t power 1, entire dimension l power 1, t power minus 1. Everybody know, and m power 0. ये तो हो चुका है, right? And linear displacement can be ds divided by dt, rate of change of, ये भी पता है from lower class. ds and dt doesn't make a sense. Ultimately quantity, it is a linear displacement. Linear displacement matlab length, because I told you, this is 4 time I am saying you that here displacement distance doesn't make a sense. We are not interested in direction, we are interested in its magnitude, and displacement ka magnitude is length. Displacement magnitude is length. A particle moving with a displacement of 40 meter, no doubt that 40 meter is the length between the 2 points. No doubt there is a direction also, but we are not interested in direction, because right now I am doing dimension. So here angular velocity omega का formula क्या होगा? Use a logic. Sir, linear velocity is linear displacement upon time. Angular velocity is angular displacement upon time. Angular velocity is angular displacement upon time. So logic. Linear velocity is linear displacement upon time. Angular velocity is in the circular motion, rotational motion concept chapter. जब तक ये चैप्टर्स नहीं चालू होगा, एंगुलर वेलोसिटी कंसेप्ट्स यू आर नॉट गोइंग टू फेस. सो मजा कर लो till the chapter 5. As soon as in chapter 5, I and Sir Rumit sir will start with circular motion, immediately we will come across the quantity called angular velocity, because it is moving on the circular path. मैं इसलिए इतना सिखा रहा हूँ मेहनत करके. Please take care of this. So this is angular displacement upon time, linear velocity, linear displacement upon time. So angular velocity omega, the formula होगा d theta divided by dt. Oh, beautiful. Because angular displacement is d theta. That is angular displacement divided by dt. Well, linear displacement is ds. Class 9th, ds. dr. You can write dr. No issue, sir. dr. But dr is what? Ultimately displacement. No? So denotion by length only. So here d theta by dt. So what is the dimension of angular velocity? Dimension of omega is equal to dimension of d theta divided by dimension of dt. Oh God. So now a dimension of angular velocity. Sir, dimension of angular displacement. Sir, it is a plane angle. Sir, it is a plane angle. Angular displacement is a new name now in this topic when the rotational motion or circular motion concept is concerned. The earlier, which was a plane angle, length of an arc upon length of a radius, the plane angle topic is now angular displacement. Oh God, so it is dimensionless. Numerator, it is dimensionless. So it is L0, M0, T0. भले ये angular displacement है right now, but it is a plane angle. It is an angle. It is a displacement in the form of angle. Angular displacement is a displacement. Agreed. Displacement. But in the form of angle. Since it is a displacement in the form of angle, angle don't have dimension. So here L0, M0, T0, numerator, and denominator it is time. Don't worry with D, Don't worry with D. D is a small change in time. So small change से क्या करना है? The quantity is time, ना? So it is t power 1. So dimension of angular velocity is L0, M0, t power minus 1. L0, M0, t power minus 1. L0, M0, T0 and this T1 go up, become t power minus 1. Some of the book write this as theta by t also. ऐसे लिखोगे तो the best है, कोई issues नहीं है, because theta is an angle now, d theta is also a small angle, theta is some finite angle. As soon as d doesn't make a sense, d is a small change. So I can write about theta also. Okay, ये सब logic use करो. So it is theta by t also. It is s by t also. And theta is angle, dimensionless. T का dimension t power 1. Answer is this. Hey, what is the unit? What is SI unit? SI unit of angular velocity. इसका क्या unit है? Meter per second. Displacement is meter, time is second. Meter per second, na? And here also you can see L के लिए meter and second power minus 1. So it can be written as per second. What is SI unit here? Sir, theta is the unit as radian. Radian. So in numerator it is radian and denominator second. So radian per second. Superb. It is radian per second or radian second inverse. Radian second inverse. So my dear, this is the way of calculating the dimensions of angular velocity. So angular velocity and linear velocity is a logical concept. Linear velocity is taken in translational motion, in straight line motion, and angular velocity is taken in circular motion or rotational motion. Linear velocity formula is ds by dt, that is linear displacement upon time, whereas angular velocity is omega, denoted by omega, and the formula is angular displacement upon time. Logically padho, logic. Angular displacement upon time. And angular displacement is d theta or theta. It is an angle, sir. It is a displacement on circular path in the form of angle, and that angle is traces at the center of the circle. So that angular displacement is an angle denoted by d theta divided by time dt, or you can write theta by t also. Now theta is an angle, it is a plane angle, but here it is angular displacement because the displacement is in the form of angle. So ultimately it is an angle, so it is dimensionless, L0, M0, T0 divided by time t power 1. So angular velocity dimension is L0, M0, T power minus 1. And dimension, this become L0, M0, T minus 1. And unit क्या होगा? Sir, in numerator it is angle, that is radian, and in denominator it is t. So per second, answer will radian per second, angular velocity unit. So I am pausing here. जानबूझ के I have taught angular velocity. I take more time to teach angular velocity because among these 20 dimensions, some of the topic is conceptual. So take care of that because this is keep using. So now I finish with the dimension of angular velocity. Please write it down and then I will go further.